Today's lesson is lesson 8.4, rate of change. And the definition here for you, a rate of change is a rate that describes how one quantity changes in relation to another quantity. So all that means is we're going to look and see what happens to the y value as we change the x value. As x increases, what happens to y? Or as x decreases, what happens to y? Those kind of things. So rate of change is where it's at today. Let's look at some preliminary stuff. You know that this is what? What's it called?
Rectangle?
Not the green thing, the one.
Coordinates. Oh gosh. Like coordinate pairs?
Ordered pair, there you go. All right, ordered pair. We have an ordered pair, x and a y. And the thing about working with ordered pairs is sometimes you have a list of ordered pairs and you got to start working with individual numbers within those lists of ordered pairs, and you can kind of get lost in the numbers if you're not careful. For instance, if I wanted, this is just a generic ordered pair, x and a y. Well, what if I wanted to talk about another generic ordered pair, an x and a y value? Well, if I want to give you a formula and I want to use an x, which one of these two x values did I just use? Not both. They're two different coordinates. You can't use them both in one letter. And so I'm doing this to illustrate kind of what we need to, a new concept, I guess, that we need to look at here. I want to give you the idea that if this is your first coordinate that you're going to talk about, we could write it like this: x sub 1, y sub 1. And if this is x1, y1, what is this going to be? x2 and y2, correct? Okay, and so we can write just two generic ordered pairs in this way, and that way we understand this x goes with this y, and this x goes with this y, and now I can give you a formula that uses those things. Okay, so this is the rate of change formula. And it's one you're going to use a lot for the rest of the year. It's one you're going to, in my algebra class, we're using it. We've been using the rate of change formula for the last 2 months or more. And we use it all the time. So this is a big, big deal. The formula is this: y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. So when I say rate of change, that's the formula that should just pop right into your head. The other thing that you might hear me say, and they use this phrase in the book a lot, and it means the exact same thing: change in y over change in x. And sometimes I'll say that just because it's quicker to say that than it is to say y2 minus y1 over x2 minus x1. Change in y over change in x. It means the same thing though, okay? So those two phrases, the phrase is interchangeable with the formula. All right, so you know the formula. So when I ask for it on the next couple of slides, you're going to be able to tell me the formula, right? Yes. There we go. Let's look at some examples. Find the rate of change for the points 2, 5, and 4, 9. So these are 2 points on a coordinate plane, 2 ordered pairs, and I want to find the rate of change for these 2 points. So what is the formula?
5 minus
Riley, nope, formula. Riley.
y2 minus y1 over x2 minus x1.
Okay, x2 minus x1. Just like when we learn new stuff, I'm going to drill that in quite a bit. Now it's just a matter of substitution. y2 and y1. Which two numbers are my y coordinates?
9 and 5.
9 and 5. Okay, the 9 and the 5 are the y coordinates. So I need to substitute those in. So y2 would be which one? 9 minus 5. And then the x coordinates?
4 and 2.
Okay, and here's the important thing about the formula: 4 minus 2. Since the 9 comes first on top, the x coordinate that goes with that 9 has to come first on bottom. If you switch those two numbers around ever, you're going to get the wrong answer. So make sure that you have them in the right order. And then it's just a matter of doing the math. 9 minus 5 is 4. 4 minus 2 is 2. So the rate of change is 2. Or you can write it as 2 over 1. And we'll talk about why in just a minute. Now let's say I'm just working through this problem real fast, and I see my x and my y coordinates, my ordered pairs, and without thinking, I'm going to write it out this way. 5 minus 9 over 2 minus 4. Let's try it. Okay, because I have my 5 minus 9. That would actually be switching these two around, kind of, wouldn't it? And then 2 minus 4. So let's try it. 5 minus 4 is, or 5 minus 9 is negative 4, and 2 minus 4? Negative 2. What's negative 2 over, or negative 4 over negative 2?
Negative 2 over negative 1.
What's a negative over negative? Negative over negative is positive. So I still come up with the same answer. So don't get hung up on which one of the coordinates do I do first. Which one do I do first? As long as, if I put this y value first, I've got to put the x value that goes with it. Okay? Don't ever switch the x and the y values, but as long as you have them paired up right in the formula, it doesn't matter which one goes first. Okay. Let's look at some more examples. Find the rate of change for the points 3, 7, and 5, 10. Help me set this one up. Somebody raise your hand and tell me what goes on top. Austin?
Y2 minus Y1.
Y2 minus Y1. Okay. And what numbers are we going to substitute in for that, Austin?
10 minus 7.
10 minus 7. And then what goes on bottom, the bottom part of the formula? Somebody? Kari?
X2 minus X1.
X2 minus X1. And what numbers will we substitute in?
5 minus 3.
5 minus 3. So 10 minus 7 is 3, and 5 minus 3 is 2. Now here, leave it. Leave it alone. Don't change it to an improper fraction, or leave it as an improper fraction. Don't change it to a mixed number, and whatever you do, do not change it to a decimal. Please, okay? And because my standard answer is I know what's coming next, and even as we talk about some things here in just a minute, that'll make more sense, but leave it as an improper fraction. When you have a whole number, like back here, it would be totally acceptable to write this as 2 as a whole number. I don't have to have the one on bottom. But when you have an improper fraction, leave it like that. All right, let's look at this one. Find the rate of change for the points 4, 12, and 7, 6. Somebody just tell me what numbers, just tell me what the problem will look like. Lainey?
12 minus 6 over 4 minus 7.
12 minus 6 over 4 minus 7. Okay, 12 minus 6 is 6. 4 minus 7 is negative 3. So the slope will be, or sorry, the rate of change will be negative 2 over 1 or just negative 2. Either one of those is acceptable. Okay? Now, moving along, what if I don't have any ordered pairs? All I've got is a line on a graph.
You can find the ordered
I can find the ordered pairs and calculate the rate of change. So give me the ordered pairs for point A.
3, 2.
A is 3, 2, and B you guys can't see it very well. 7, 4 is B. Okay, now I have the ordered pairs. I can find the rate of change. So it would be 4 minus 2 over 7 minus 3. 4 minus 2 is 2. 7 minus 3 is 4. And then simplify 1 over 2, 1/2 is the rate of change. Okay, and leave it as a fraction. Do not write it as a decimal. And I want to show you why we're doing this. Rate of change, we've got the y is on top and the x is on bottom, right? And so what that's telling us is that as x changes 2, y is changing 1. So look what happens. As I go over 2 on my x, what happens on the y? Changes 1. And then as I go over 2, what happens? Changes 1. So as x changes 2, y changes 1. So as we look back at some of these past ones, as x changes 1, what happens to y?
Decrease.
It goes down 2. Okay? And as x changes 2, what's going on with y?
Changes 3.
It's going up 3, okay? And as x changes 1, what's happening to y? It's going up 2. So that's the whole reason that we're leaving these as fractions or as improper fractions, especially because that tells us exactly what's happening in the relationship with the line as we graph it, okay? There's where we were. All right. Find the rate of change from point A to point B, and then find the rate of change from point B to point C. So point A is 1, 2, 3, 4, 5, 6. A is 1, 6. B is 2, 1, 2, 3, 4. So this one is going to be 6 minus 4 over 2 minus 1. Oh, thank you. Wow.
They don't match up.
Thank you, thank you, thank you. I was not paying attention at all. 6 minus 4 over 1 minus 2. Good catch there. 6 minus 4 is 2. 1 minus 2 is negative 1. All right, so the slope then, or sorry, I keep saying slope. The rate of change would be negative 2. And think about what happens as my x moves once. As x moves 1, what happens to y? Goes down 2, right? All right, let's find the rate of change from point B. So let me change colors here. B is still 2, 4. What is C?
3, 2.
C is 3, 2. So 4 minus 2 over 2 minus 3. 4 minus 2 is 2, and 2 minus 3 is negative 1. So we have a slope or a rate of change of negative 2. Is that a surprise?
No.
No. And this illustrates that the rate of change for a line stays the same. Okay, so it doesn't matter what 2 points on the line I choose, the rate of change for that line will stay the same. Guess what's going to happen if we use points A and C in the formula? It's going to reduce to negative 2. Okay, so on your assignment, you're going to have some questions about find the rate of change of a linear function. Well, it doesn't matter what points you pick. Pick any 2 points on the line on the graph and find the rate of change for those 2 points. You're going to have the answer, okay? You also will have some word problems. I took this one straight out of one of the examples in the book about a kite surfer. Between which 2 consecutive points did the height of the kite surfer increase the most? Find the ratio of the change in height to the time for each section of the graph. And so what this problem wants us to do is find the rate of change for all 4 sections of the graph. You have A to B, B to C, C to D, and D to E. That's 4 sections of the graph. And so all we would have to do is find the ordered pairs for each of those points and find which one had the greatest rate of change. Now, looking at the graph, what do you suspect is going to be the answer? Which section has the greatest rate of change?
B to C.
From B to C. You can see it on the graph. That when we go over 1 on the x, what happens? It goes up 3. Okay? And so I won't take the time to go through all of these. You'll have 1 or 2 on your homework probably where you need to do all the points and then make the answer and show all your work and everything. But I want to illustrate one thing that's happening from point C to point D right here. What is the rate of change from C to D?
2.
Okay, let's get the ordered pairs. C is 6, 10. And D is 10, 10. So let's plug those numbers into the formula. 10 minus 10 over 6 minus 10, which is 0 over negative 4. Anytime you have 0 divided by a number, what do you get? 0. So the rate of change is 0. A horizontal line has no change, no rate of change. Okay? Now, we've looked at ordered pairs, we've looked at graphs. If they give you a graph, just find the ordered pairs and use that information. Now we're going to look at a table. Alice uses a pedometer to keep track of the number of steps she takes on a walk. Find the rate of change. Well, They've written it in a table, but we still have X and Y values, right? So 480 minus 288 over 5 minus 3 equals
208. Oh.
how about 192 over 2? So that would reduce to 96. And if we're talking about number of minutes that she walks, if she walks 1 minute, it takes 96 steps. That's pretty good rate she's moving at, right? And then we would be able to use that rate to predict how many steps would she take in 10 minutes or 20 minutes or whatever if she continued at that same rate. So the other thing that this illustrates for us, back in chapter 6, I told you a rule about where time goes. Time goes on bottom. And this is why. Because time is almost always, time is going to be your X value on a graph. And so we're talking about for every minute, she takes 96 steps. Okay, so X is the time, it goes on bottom. Where does money go?
Top.
On top. So if they don't tell you what the X and the Y values are on the graph, you still need to be able to determine what the X and the Y values are. So if they give you anything in relation to money, that goes on top where the Y goes, right?
What does tell you the top and the X and Y?
Well, it'd be the amount Y remaining in Lord's account. So 160 minus 120 over 4 minus 6. So 40 over negative 2 is negative 20 over 1. And what does that mean? Negative 20 over 1. What does that mean in relation to what we're...
X goes over 1, Y goes up 20. Well, it goes down 20.
Goes down 20. So every week, what's she doing to her savings account? She's taking $20 out. Okay, that's good. All right. Here's your homework.